Okay, so the next question is: a lorry is at rest on a straight horizontal road. A constant driving force of 5.4 into 10 to the power 4 Newton acts and it accelerates forward. So acceleration is change in velocity per unit time. So over here, 2 marks are awarded for change in velocity and for time. Next question: as the lorry moves forward, work is done on it by the driving force. The equation that defines the work done. Okay, refer to the direction of the force exerted. So, work done will be equals to force multiplied by distance moved in the direction of force. Okay, calculate the work done on the lorry by the driving force when the lorry travels a distance of 280 meters. So force into distance, the force that we have is 5.4 into 10 to the power 4 newtons multiplied by 280 meters as given. So if we calculate, it will be 1.5 into 10 to the power 7 joules. Okay, next question. At one point on the road, the kinetic energy of the lorry is 3.2 into 10 to the power 6 joules and its speed is 12 meters second. Calculate the mass of the lorry. So over here we have to use kinetic energy. Ke will be equals to half mv square, which is equals so we rewrite the equation and make m the subject of the equation. M equals 2 multiplied Ke, kinetic energy, divided by v square. Now we place the values. So 2 multiplied the kinetic energy that is given is 3.2 into 10 to the power 6 divided by the velocity is 12 square. So which will be equals to 4.4 into 10 to the power 4 kg. So we'll be awarded with 3 marks if we do all the steps correctly. Next question. Okay, next question is: when the temperature of the liquid increases, the kinetic energy of the particles. So referring to particles when heated, the kinetic energy of the particles increase as well as their distance between particles. So the forces of attraction between the particles decreases and they expand. Okay, so moving on to the next question. The heater in a kettle is near to the base of the kettle. The kettle is filled with water at a temperature of 17 and the heater is switched on. So state the name of method of thermal energy transfer. Now touching the heater, base will be conduction. So we write conduction. Explain how thermal energy is transferred through all of the water in the kettle. Now this is about liquid heat transfer. So convection is the best way. Convection. Now what does convection mean? We just need to write, and how does it occur over here? So density of water just above the heater at the bottom of the kettle decreases due to heat and less dense water rises up and cold water sinks to the bottom, establishing a convection current. Okay. Moving on to the next question. Say the boiling temperature of water at standard atmospheric pressure. The unit in your answer. So it will be 100 degrees Celsius or 373 Kelvin. Okay. The kettle contains 2.5 kg of water at standard atmospheric pressure. Specific heat capacity is 4200 joules. When the water reaches its boiling temperature, the kettle switches off. Calculate the increase in the internal energy of the water. So internal energy increase will be equals to E mc del theta. So over here our m is 2.5 kg multiplied by 4200 multiplied by the temperature difference, that is 100 minus 17 degree, and it will be equals to 8.7 into 10 to the power 5 joules. Okay, moving on to the next question. So red light of frequency 4.7 into 10 to the power 14 travels in air at a speed of 3 into 10 to the power 8 meter per second. Now calculate the wavelength. So we will be using the wave equation v equals to f lambda. Over here lambda will be equals to v by f, and v is 3 into 10 to the power 8 divided by 4.7 into 10 to the power 14, so which will be equals to 6.4 into 10 to the power minus 7 meter. Okay, it shows a narrow beam of red light striking the surface of a parallel sided glass block, rectangular glass block, as we can see. So instead, what happens to the speed, to the frequency, and to the wavelength of the light? So speed decreases, lighter to denser medium, that's why. The frequency, it remains the same, and the wavelength also decreases. It's kind of proportional to the speed. So yeah, using those angles, calculate the refractive index. So n equals to sine I by sine r, and n equals to sine of I. As we can see, the incident angle is 45 degree and the refracted angle is 30 degree. So sine of 45 divided by sine of 30 will give you approximately 1.4. So the refractive index is 1.4. Now the light continues along the path until it strikes the bottom of the surface of the block and then emerges into the air. Now we need to draw the path taken by the light until it strikes the bottom surface and the path of the light that emerges. So over here, we first, for better view, we rub the angles, and now we continue with the line, the refracted line, and it goes to the bottom of the glass block. Then we draw a normal, and from the normal we can see that there is a red light which is supposed to appear like this. So it will also appear the same as that of the original incident ray. Both these will be parallel to each other. Okay, so yeah, that's the drawing. Next question. Most of the energy emitted by the sun is in three regions of the electromagnetic spectrum. The name of one of these three regions is ultraviolet region. State the name of all three regions in order of increasing frequency. Now, the smallest frequency that we can have is IR, or infrared lights. Intermediate frequency that we can have is visible light. And the largest frequency that we can have is ultraviolet, or we can write for short UV. The next question: so the ultraviolet radiation emitted by the sun reaches the Earth's surface. One possible damaging effect to human body and one property of ultra that causes this damage. So damaging effect is it can cause cancer. Now the property, okay, the property that we have that causes this damage is the ionization. So we can write as it is ionizing. Electromagnetic radiation is a transverse wave. The difference between transverse and longitudinal, so transverse we have to define. Transverse wave, it travels, so the vibration of the particles is perpendicular to the direction of wave travel. Longitudinal wave, on the other hand, it vibrates or travels parallel to the direction of, yeah, that would cover 2 marks.